You may hear my dog in the background. She's eating her supper, so she's a little bit noisy, but that's the noise in the background if you can hear it. All right, for this worksheet, we're going to look at adding and subtracting unlike fractions. Okay, so what does that mean? Well, unlike fractions are fractions that have different denominators. Okay, so unlike fractions, they have different denominators. For example, 2/3 and 3/4 are just one example of unlike fractions. Okay. Now, we have to go back and kind of remember some stuff. So, one thing that we need to understand is from the previous worksheet. In the previous worksheet, we found that we can add fractions that have common denominators. Those are called like fractions. So, we can add like fractions by adding or subtracting the numerators and keeping whatever the common denominator is. Our last step was to simplify. So, for example, if we had 2/5 plus 1/5. These are like fractions. We would add the numerators, so 2 plus 1 is 3, and then we keep it over 5. We know how to do that. Our issue now is what do we do if our fractions have different denominators, okay? Now, our goal is when presented with addition or subtraction of fractions with unlike denominators, our goal is to create equivalent forms of each fraction using the LCD. We also talked about this in the previous worksheet. We learned how to find a least common denominator and what it was, so what it was and then how to find it. And we also learned or reminded ourselves how to find equivalent forms of fractions. So remember, the least common denominator, we generally call this the LCD. It's the smallest multiple all of the denominators have in common. And there were a couple of different ways that we could find the LCD. So let's practice. For example 1, it says find the LCD of each pair of fractions, find equivalent forms for each fraction using the LCD. So we had two methods. One method was just to list out multiples until we found one in common, and then we had another method where we created a table to find the LCD. Let's do one of each here. So for part A, let's just list out multiples. So we have denominators of 3 and 4. So we want to list out multiples of 3 and 4 until we find one in common. Okay? So you find multiples by multiplying the number by just non-zero whole numbers or natural numbers. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Let's stop there. I feel good about this. Okay? Now, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And at that point, we can stop. We have a multiple in common. So we can now say that the LCD is 12. So we know the least common denominator. Okay? What we now need to do is find equivalent forms of both of these fractions using 12 as the LCD. Okay? So let's say we start with 2/3. Now we know that we want 2/3 to have a denominator of 12. So the issue is, what would I multiply my current denominator by to get my LCD? What would I multiply 3 by to get 12? Well, hopefully at home you're shouting out 4. So we want to multiply 3 by 4. 3 times 4 is 12. But if I multiply the denominator, I have to multiply the numerator by the same thing to maintain this fraction, maintain the value of the fraction. So I'm going to multiply the top by 4 as well. Well, what we have secretly done is we've multiplied by just a weird form of 1. And remember, just basic math. We have a multiplication property of 1. If you multiply anything by 1, you get the same thing back. So any number times 1 is just that number. The same thing is true with fractions. We may not have a fraction that looks the same, but we have a fraction that is equivalent. Okay? So when I multiply my numerator of 2 by 4, I get 8. So we now have that 8/12 is exactly equal to 2/3. Okay? And we want to just repeat this process, but this time with 3/4. So I want to rewrite 3/4 as an equivalent form with 12 as the denominator. So I ask myself, what would I multiply 4 by to get 12? Well, I would have to multiply 4 by 3 to get 12. And if I multiply the denominator by 3, I better multiply the numerator by 3 as well, because that gives me that form of 1. Well, 3 times 3 is 9. So I now have that 9/12 is exactly equivalent to 3/4. So what we've done here is we've found an LCD and we have found equivalent forms of our fractions. And remember, if we go back up here to this recall statement, we know how to add fractions that have common denominators. Well, these two fractions now have common denominators. Okay? Let's look at part B. So for part B, we have 1/6 and 7/20. We need to first find an LCD, and then we need to find equivalent forms of these fractions. So let's do the prime factorization method here. So when you do the prime factorization method to find your LCDs, you want to start by finding the prime factorization of each of your denominators. So 6 is easy. I just need to rewrite it as 2 times 3. 20, also pretty easy. I need to rewrite 20 as a factorization using any two factors. So let's say we use 4 and 5. Well, 4 is not prime, unfortunately, so we have to rewrite 4 as 2 times 2. But then 5 is prime, so we just bring it down. Okay? And then we scoot over to a table. So I have a table that has a row for each denominator, and then it also has a row for the LCD. And what I do is I fill in one of my denominators, as is, just the factorization, and then I want to fill in the other one overlapping columns as much as I can. So let's say we start with 20. I generally start with the denominator that has the factorization with the most factors in it. I just find that to be easier. It doesn't really matter, but I'm going to start with 20. So 20 is 2 times 2 times 5. That means the first column can only contain a 2. The second column can only contain a 2. The third column can only contain a 5. So we want to overlap the factors of 6 using as many of these columns that are already here as possible. So when we look at 6, we have a factor of 2. Well, that 2 can go in either of the first two columns. Literally does not matter which, pick your favorite. And then we have a 3. That 3 cannot go in the 2 column. That 3 cannot go in the 5 column. So unfortunately, we do have to start a new column for the 3. I have 4 columns. That tells me my LCD is going to have 4 factors. So basically, you bring down the representative from each column. So the first column is a 2's column, so I bring down a 2. The second column is a 2's column, so I bring down another 2. The 5 is the 5's column, or the 5 is the 5 column. I bring down a 5 for the 5's column, and then I need to bring down a 3 for the 3's column. So basically, you just multiply across for the columns. So however many columns is however many factors you're going to have in your LCD. So let's see what we get here. 2 times 2 is 4. 5 times 3 is 15, and it just so happens that 4 times 15 is 60. So this right here is my LCD. Okay? So now what we want to do, what did I just do? Now what we want to do is we want to find equivalent forms of both of these fractions using the LCD of 60. So we have 1/6. I know I need to rewrite that as something over 60. I want equivalent form of 1/6 with 60 as the denominator. So I ask myself, what would I multiply 6 by to get 60? That would be 10. And if I multiply the denominator, I have to multiply the numerator because that gives me that weird form of 1. So I'm really just taking 1/60th and technically just multiplying it by 1. So I'm not changing its value, merely changing its appearance, okay? So 1 times 10 in the numerator becomes 10. So 10/60ths is exactly equivalent to 1/6. All right, and then we repeat the process for 7/20ths. So we ask ourselves, what would we multiply 20 by to get 60? Well, I would have to multiply 20 by 3. So I multiply top and bottom by 3. That's my weird form of 1. So then 7 times 3 is 21. 20 times 3 is 60. So 21/60ths is exactly equal to 7/20ths. Okay, so again, we found an LCD and we found equivalent forms of these fractions, and this is pivotal because now I have two fractions that have common denominators, so I could easily add or subtract. Okay, so make sure you understand this method because this is the process we're going to have to use to add or subtract what are called unlike fractions.